tutorial, I want to show you how to display a U chart, a U control card in your DMAIC projects when you're in control phase, when your Y is discrete or attribute type. First thing, when you will open the tool, control card U in DMAIC Suite, you will find this table and this chart. And you have to know that all cells in blue are protected, meaning you cannot delete them, but you can see the formula, if there is one, on the top bar. Every white cell, this is where you enter your data. For example, my process improvement project. You can enter the date. Let's say we are in May, your name, and what you measure. It could be CPU of my assembly line. And this card is called U chart, and it's a card where you will compute the proportion of defects, of all defects among all the parts that you produce. So if, example, at your factory, if you have shifts and runs, you look at how many parts were produced in a run, how many defects you have in parts. And here I am speaking of defects, not of defective or non-conform parts. Defects meaning one part can have multiple defects. So for example, let's say that if on one part I could have 5 opportunities of defects, each time I produce a part, I could have either 0 defect on the part, 1 defect, 2 defects, 3 defects, 4 defects, 5 defects, etc. So here I want to calculate and compute all defects that I found on all parts that I produced. This is called defect per unit, and this is exactly why this U chart, control chart, is made. This is for defects when we compute rate of defects among produced parts. So you will find here that we enter the number of defects, and here we enter how many parts we are sampling or producing, and the tool will calculate the defect rate of the DPU, and each point here will be a DPU. So 9 divided by 302 parts will give 2.98%, and we will continue. And of course, you can enter up to 20,000 data, so you are not limited to build your control card. The control card you have here is made of DPU that I measure over time. Here I have 36 points. You can see that I have 0 defects, so 0% of defects here, DPU, 0 defects per unit. And here, if there is variation, so I can calculate with your 36 defects per unit over time, the mean or the average value of DPU, that is called U bar, like U chart, bar like X bar, so the mean of the DPUs, but is a little bit below 1%, which equals 0.91%. I can compute the standard deviation of your DPU, of course, that you compute over time. So if I have an average and I take 3 times the standard deviation, I will have what we call the upper control limit of the U chart. And here, the lower control limit, which is limited to 0%, of course. And the same thing applies on all control charts. If the points that I am looking on the control charts are within the control limits, I am in control, my process is in control. If I have points like in this example outside the control limit, above the control limit, we are considered, statistically speaking, out of control. And this is also, statistically speaking, due to a special cause, each one. Probably a different or the same one, but we need to investigate and to fix that so that we come back to control. And this is why the control card is used to monitor your process and to understand if you are under control, statistically speaking, over time. That's it. So let's just add one example. Etc., etc. Thank you.